Recently, a tech news story leaked that sent shockwaves through the entire industry. A major enterprise company reportedly received a $500 million bill in a single month for their employees' use of Anthropic's Claude AI. $500 million in 30 days. How is that even possible? It comes down to a major shift in how we use AI. Right now, most people use ChatGPT or Claude for simple tasks, like writing an email, translating text, or explaining a coding concept. These are short, one-off chats that only consume a few thousand tokens. But the industry is moving toward AI agents. These are long-running, autonomous workflows. You give an agent a task, and it runs in a loop for hours. It scans code bases, runs terminal commands, reads errors, and corrects itself. Every single step in that loop resends the entire chat history and code base back to the cloud. When hundreds of employees start running these autonomous loops all day, you get what the industry calls token maxing and a $500 million API bill. Running AI agents in the cloud is financially unsustainable. It is a cost so high that regular people and small businesses will never be able to afford it. And that is why the future of AI has to be on device. The hardware giants know this. They see the writing on the wall. That's why NVIDIA recently launched the DGX Spark, a compact, personal AI supercomputer designed to sit right on your desk. Powered by the massive Grace Blackwell superchip and featuring 128 gigabytes of unified system memory, this isn't for gaming. It is built to run massive, long-running agentic loops locally on your own hardware. And for laptop users, NVIDIA introduced the RTX Spark platform, bringing this exact high-bandwidth, unified memory architecture into thin Windows laptops. They are building these machines because they know that if you want to run an autonomous agent that codes for you all day, you cannot rely on cloud APIs. You need a local supercomputer in your room or a local NPU chip in your pocket. But running these large models locally comes with a massive bottleneck, and it's not what you think. You see, large language models are memory bandwidth constrained. Every time the local model predicts the next word, it has to read the entire weight database of the model from your system's RAM. This is why Apple Silicon M-series chips have dominated local AI for years. Their unified memory architecture allows the CPU, GPU, and neural engine to share the exact same high-speed pool of memory, reaching bandwidth speeds of up to 400 gigabytes per second or more. This is also why NVIDIA is focusing so heavily on unified memory for the DGX Spark and RTX Spark. The battle for local AI isn't just about raw processing speed anymore. It is a war over memory bandwidth. When you shift to local AI, everything changes. It comes down to three massive pillars. First, privacy. When an AI agent is scanning your entire codebase or looking at private company documents, you cannot have that data streaming to a third-party server. Running it locally means your intellectual property stays in your silicon. Second, latency. Local AI works instantly with zero queue times, even if you were offline, on a plane, in a subway, or deep in the mountains. And third, cost. Instead of paying Anthropic or OpenAI for every token you consume during a long-running agentic loop, local AI runs on your own electricity. It is completely free. You can run loops 24/7 and pay absolutely nothing. But how do you fit a model that took millions of dollars to train onto a standard computer? The secret is quantization. Researchers have learned how to compress these massive models from 32-bit floats down to 4-bit integers, reducing the RAM requirement by 80% with almost no drop in intelligence. Today, models like Meta's Llama 3 or Microsoft's Phi 3 can run comfortably on standard, everyday hardware. The future of AI isn't a choice between the cloud or your device. It is a hybrid world. Heavy-duty training tasks will stay in massive data centers, but your daily agents, the ones that code for you, manage your schedules, and run your workspaces, will live safely inside your local hardware. What local AI tools have you run? Have you checked out local models like Llama or Gemma? Let me know in the comments below. And see you in the next one.